Unit 9 of Math 114, Quantitative Reasoning. It's on percents and frequency. We have some of the same percent problems and ratios that we had in Unit 8. So we still are going to talk about percents and parts and percent increase and percent decrease. But what we're going to do this unit is we're going to add a little bit more on the statistics side of things. So we're going to talk about things in terms of frequency, cumulative frequency, and relative frequency. So to give you a quick introduction to that, I wanted to show you this frequency table here, okay? And what we have here is we got a table from a chart, a table that shows the frequency of people in each weight. So we have 22 total people, and there are 3 people that weigh in this range, and there are 6 people that weigh in this range, and you'll notice that it adds up to 22 because that's the total, okay? That's what frequency means. It's just what do we have in each category. The cumulative frequency is a little bit different because we say, what do we have in the category, or what do we have in the category before it? So in this case, the cumulative frequency is going to be not just 6 for the second part, but 6 plus what we had before, which is 3. So instead of just being 5, we're going to say 5 plus 9 is 14. And then 6 plus 14 is 20. And then finally, 20 plus 2 is 22. We also have a relative frequency, okay? And whenever we see relative, really what that means is we're going to divide by our total. And so each one of these relative frequencies are the are the frequencies over the total. So this is 3 over 22, and that's where we get the 13.64%. Those are decimals. We could also notice that they do add up to 1. It is possible that they could be off just a little bit if they rounded funny, okay? So they could be off just by 1%. Let's look at a percent increase problem. Now, when we're doing Unit 8, we gave you very straightforward math problems, but now what we're doing is we're trying to put them in context, real context for you. So in this example, we have Clint, and he has a salary, and he got a raise. Good for him. His salary increased from $21,000 to $35,700. So did he get a $35,000 raise? No, because we have to take his new raise, his new salary, divide it by his old one after we subtract it. And so what we see when we do that is we get Clint's percent increase. And actually we got 0.7. So as a percent, we'd say that's 70% because we'd have to move it 2 decimal places. Now, Helen also got a raise. Ellen got a raise all the way to $44,200, so even more money. But to be fair, Helen did start out already making more money. And so if we subtract those to find out how much money she made, well, she made how much money in absolute terms? In absolute terms, we'd say she made, oh boy, what is this? This is 20, no, not quite 20,000, but 18,000 for, no, 18,200. She got an $18,000 raise. That's fantastic. I'm happy for her. Now, if we were to subtract Clint's salary, he didn't make $18,000. So in absolute terms, what we'd say is Helen made more. She got a bigger raise. However, what we'll notice if we divide by what she started with, Helen has the actual same relative raise. And so they both got a 70% raise, but in absolute terms, Helen got more. So in absolute terms, Helen got more, but in relative terms, they actually got the same. Let's look at another example with percent and percent increase. And the point I want to make with this problem is the difference between a percent change and percentage points. So we have an absolute change in percentage points and a relative change in a percentage. Now, a lot of times you'll hear stats on the news and they won't really specify whether they're talking about an absolute change of percentage points or a relative change of a percentage. we use this when we have percents that we're talking about. So in this case, it went from 68 to 82. So we're going to go ahead and take the 82 and subtract what it started at 68. And that would give us 14. Now that's 14 percentage points increase. That is not an increase of 14%. So that's a percentage point increase. I just subtracted. So in absolute terms, that's 14 percentage points. Notice I didn't write the percent symbol. Now in relative terms, I take that absolute and I divide by what I started with. And when I do that, that percent is what's going to go right in there. I'm going to go ahead and use my calculator and figure this one out. I'm pulling out my handheld calculator. 14 divided by 68. And I got like 20.20588. And it kept going. But I need to round it to the nearest tenth. That means one decimal place. So after I multiply by 100, I'm going to get 20.6%. So notice that those are different because percentage points are not the same as a percentage. This is one of those deceptively tricky problems. So I want to show it to you because usually the first time you look at this problem, you might think about it backwards. And that's because it's written backwards. So it says the diner's frequency would add a 15% tip. And so when we go ahead and pay, if we got and we price the meal and we charge $31.05, including tip, that's including tip. How much was the tip? Okay, so if that's including tip and we want to know how much was the tip, we can set up a percent problem, but I want you to notice this is not 15%. Okay, if we set it up as 15% over 100% and we try to find this, what we're going to find is that we were charged $31.05, but it actually cost us hundreds of dollars to eat this meal, and that's not true. Okay, so what are we missing? We're missing the fact that $31.05 is not just the tip. It's not just the percent of the tip. It's also the whole meal. So we need to put that $31.05 equal to 115%. Now when we set this up and solve, we're going to go ahead and cross multiply and divide. And when we do that, I got $27 even. Okay, now, so my answer is $27. Well, actually, it's not $27 because I was trying to set this up and I wasn't paying attention to what I'm looking for. So whenever I have a word problem, I like to check before I submit my answer. I look at what was the question actually asking. And if you look at the question was how much was the tip? Do you think we tipped $27? No, that's too much. That's not the tip. That's 100%. What I need to find out is what the 15% was. In other words, I could either go reset this up and change this right here to 15% instead of 100%. I could do that, or I could take what I have here and subtract it from 31.05. So that's what I'm going to do. I'm going to take the 31.05 and I'm going to subtract 27. And what I ended up with is a tip of $4.05. All right, these are not percents. This is a table of values, okay? But they're not percents. In fact, they're counting the total number of customers that we had at this restaurant, okay? And so there were 140 total customers. And what we know out of that 140 is that 60 of them chose wine. Okay, so our question is then, how many did not choose wine? So this isn't going to be too tricky of math. We're going to say 140 minus 60. We're going to get 80. And so that's what we're going to put right there. And so we got 80 right there. And then we're going to kind of fill this out like sudoku, okay? So now we've filled out that whole total column, but we're going to look for anywhere else we might be able to fill out. So I notice that I can fill out this part right here, okay? Because I know that 60 people total, ordered wine, and 39 of those people ordered the vegetarian. And so that leaves 21 people to order the fish or the meat. All right, now I can actually use that number to calculate how many total people ordered fish or meat. Okay, I can calculate that real quick by saying 21 plus 54, and so I get 79. Now you'll notice that I have two totals. I've got the total overall, and then I got my meat and fish eaters. So I can go ahead and take the 140 and subtract 79 to go ahead and get 61 for my vegetarians. Okay. Out of those 61 vegetarians, now hopefully you can see that there's only one space remaining. And so we're going to go ahead and subtract our 61 vegetarians. We're going to subtract the 39 people that got wine. And that means that only 22 went no wine. And so we can kind of see how this breaks down. This is a little bit solving a sudoku. Obviously, there was one place in particular I wanted to start with. I wanted to start someplace where I had two things and I was just missing one entry. And then like a sudoku, you kind of work your way around to any place where you've got all the pieces except for one. Now, when we talk about statistics, it can be very easy to misunderstand what's being said. Okay, so first I want to explain how these statistics are both true. Now, we could say that a new drug reduced cancer incidence by 50%, and that sounds amazing, and it is, right? A new drug reduced cancer incidence by 50%. That's awesome. Okay, does that mean everybody should go get that drug and it should be required for everybody? Because obviously that's going to reduce cancer by 50%. Not necessarily. Okay, because if we're talking about this, we need to recognize whether we're talking about relative risk or absolute risk. Okay, and so when we talk about relative risk, we're looking in the situation that we're dealing with. But absolute risk talks about the big picture. Okay, so the big picture is in real numbers, how many people got cancer. Okay, at first 2, and the people that took the medication got 1, so that's only a decrease of 1 less person got cancer. Okay, now every life matters, and so that drug did successfully save a life, right? We've reduced cancer, but that doesn't mean that 50% of cancer is going to go away. You have to look into the context of what we're talking about. So let's stick with this kind of negative topic when we're talking about cancer. And let's look at an example, and we're kind of connecting our counting tables with that idea of relative versus absolute, taking into context. So the first question says, suppose a patient has a positive mammogram. That's what it says. Suppose a patient. So if we look at our table, where are the positive mammograms going to show up? They're going to show up right in this row. So we focus on whatever row or column we're talking about. And then the next thing we do is we say, what section of that column do we want? And it says, what is the chance that she really has cancer? Okay. So cancer, when we say cancer, in this case, we're going to use the word malignant as interchangeable for cancer. That's not necessarily a one-for-one, but I wanted to use it anyway. And so what you'll notice is we've got that column and that row. And so we're going to use the 85 that's in both for our numerator, 85. And we're going to divide it by our total. But we're not talking about the absolute. We're not talking about the big picture, okay? So don't put 10,000 on the bottom. When we talk about total, we need to say, well, total of what? Total of the context. We said, first off, they have a positive mammogram. So the total that has a positive mammogram is right there, okay? So the total needs to be the context total. And if we go ahead and type that in, we're going to get our percent, okay? Let's look at another one. It says, what is the chance of a positive mammogram? What is the chance of a positive mammogram given that the patient has cancer? So what is my context? Is my context that they have a positive mammogram or that they have cancer? It says given, which is kind of our given is our given. Given is our giveaway. for what we're looking at here. It says, given that the patient has cancer, so that means we're going to start by looking right here. And it says, what is the chance of a positive mammogram? And so a positive mammogram is going to be right there. And so we can go ahead and answer our question with, again, 85. But our denominator this time is out of 100. Suppose a patient has a negative mammogram, okay? So in our third example, suppose our patient has a negative mammogram. So I'm going to go to negative mammograms, and this is our category that we're dealing with. This is our context. And then it says, what is the chance that they have cancer? And so we're going to look for, well, that's just 15 people. Out of how many? Well, out of the 8,575 patients. So when we do these, what we're going to do is we're going to look and make sure we're paying attention to the context. It's not always what comes first. Notice that in this one, it's not what came first. It told us given gives us our context. Let's look at confidence interval 1 real quick. We don't need to go into super depth on confidence intervals. As we get deeper in statistics, yeah, we can do some more confidence intervals. But in basic terms, what we want to say with confidence interval, you hear these all the time, is you say, yeah, we're going to make an estimate. So let's say the estimate is 45%. And then we say that there's an error. We're not necessarily, we've done a sample, we did a study, but we're not sure that it's exactly 45%. We're pretty sure. And so what we can say is that we can give our error. And in this case, it says plus or minus 4 points. And so that means our confidence interval is actually going to be from 41 to 49%. Now, that is not the answer to this question because I'm just telling you what a confidence interval is. Confidence interval gives you the answer in a range. It says between these percentage points. Now, why is that not the answer? Well, that's not the answer because we're answering the wrong question. So when we look at this problem, it says the majority of people are not in favor of legalized abortion. And so what we need to do is we need to look at the percent that is not in favor of legalized abortion. But that 45% was in favor. So our actual percentage that we're going to use is 55%, because that adds up to 100, are not in favor. And then we can subtract and add our 4. So we're going to end up with 51% to 59%. Now we should do this at least once. We should do this frequency table. So the way this works is we're going to build a frequency table, and we're going to calculate the relative frequency and the cumulative frequency. So we've got our data up top. And what I'm going to do is first, I'm just going to make tally marks and build my frequency table with tallies. So I'm going to look 74, I'm going to cross it off, and I'm going to put a mark, a tally, between 70 and 75. 72 also goes there, 89, 66, 97, 77, 69, 66, 96, 72, 82, 71, 98, 70, 64, 92, 85, 99, 76, 87. And so I end up with 4, 2, 3, 2, 5, and 4. Okay, and so those are my frequencies. How many times do we have a score in that range? And so we have it. What is my total amount of frequencies? Well, if I add those all up, 1, 2, 3, 4, I end up with 20. Okay, so when I do my relative frequency, what I'm going to do is I'm going to do 4 divided by 20, or 2 divided by 20, or 3 divided by 20, and convert that to a percent. And so 4 divided by 20 is 20%, 10%, 15%, 10%, 25%, and 20%. Now, double check that our relative frequency adds up to, yeah, it actually adds up to exactly 100. That's perfect. Now, when we talk about cumulative frequency, cumulative means how many do we have in this category? Or how many do we have in this category or any category before it? So we say in the first category, there's 4, right? But in the second category, there's 4 plus 2. There's the 2 in that category and the 4 that came before it. So we get 6. In the next category, there's 3 plus the 6 that we already had, so 9. And then we have 2 plus the 9 we already had, so 11. We have 5 plus the 11 we already had, so 16. And we have 4 plus the 16 we already had, which is 20. And the good news is we were supposed to add up to 20, so I like that. I want to show you one more problem before I cut for the day, okay? Check this out. These are numbers in order, okay? It's kind of hard to see that they're in order, but I want you to notice they kind of go down this way and then down in the second, down, 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 okay? So we can kind of see that they're in order. And what we have here is we've got a request. It says, go ahead and find Q2, Q1, and Q3. So first off, it puts them in a weird order. Why did it say Q2 first? Well, Q2 is what we're going to find first. Q2 is the median or the second quartile. So the median is our middle number. So if we kind of look in order, what we'll see is our middle number is going to be 480. That's the number exactly in the middle. If we look for Q1, what we're looking for is the lower quartile. And so that's like the median of the lower half. So if we look, this one's kind of tough, but if we go 1, 2, 3, our middle is going to be 420 on the lower half. Okay, it's halfway. It's the middlest number on the lower half. Okay, right about there. And then for Q3, when we look at the middle number on the upper half, which one are we going to see? And so I think what we're going to see is 1, 2, 3, 4, 5, 6. I think it's kind of in between these two right here, because I got 4 numbers here and 4 numbers here, kind of in between those two. So I might say that is 600. Okay. And so what we're trying to do is find the lower quartile and upper quartile and the median. Feel free to try. Check this out. Try this problem on your own. Feel free to put the answers down below. See if anybody agrees or disagrees with you. What do you want to learn next? Let me know.